this is Ms. DB, and in this video we are going to learn how to solve systems of equations with elimination. This is from Chapter 6, Section 3. Our objectives are to solve systems of linear equations in two variables by elimination. And also, as we're doing this, we want to kind of think about when would be the best method for solving systems of linear equations. So far we've learned about graphing to solve. We've learned about substitution, and now we're going to learn elimination. Our goal for elimination is to get one equation that has only one variable. So when we were looking at solving equations, we knew that if you add the same amount to both sides, then our equation will stay balanced. It'll stay equal. So in this system of equations here, x minus 2y equals 19 and 5x plus 2y equals 1, since 5x plus 2y equals 1, we could add 5x plus 2y to one side of the first equation and 1 to the other side, and the balance is maintained because they're equal to each other. In other words, what we're going to do is we're going to add these two equations together. So we're going to add the x's, we're going to add the y's, and we're going to add the numbers together. And we can do this because it's the same as adding the same thing to both sides of an equation. Now, sometimes your system of equations is set up already for elimination, and sometimes it doesn't do any good to add the two together. So before we add the two equations together with elimination, we want to make sure that there is a term that has opposite coefficients. So for example, we want negative 2y and positive 2y. Those are opposite coefficients, negative 2 and 2. So then when we add them, let's go back to this. When we add these together, these terms here would eliminate because negative 2y plus 2y is 0. And then we'd just be left with 1x plus 5x is 6x, and 19 plus, oh, I went backwards. 19 plus 1 would be 20. So you could move on from there. So you want to make sure that there is always opposite coefficients before we continue with our elimination. Otherwise, it's not yet set up, and we'll have to do some more work before we can do that. All right, so here's our steps for solving systems of equations with elimination. First of all, make sure that you have the terms aligned, like x first, then y, then the constant on the other side of the equal sign, something like that. Okay, step 2 then is to eliminate one of the variables and to solve for the other variable. Now it's called step 2, but really that's most of the work of the problem. Step 3 then is once you know what one of the variables is, just like in substitution, you plug it back into one of the original equations and solve for the other variable. Step 4 is to write it as an ordered pair and check. So again, that could be step 4 and 5. 5 could be its own step of check. All right, so later on we're going to learn how to multiply one of the equations in order to set up the equations for elimination. But first let's look at what would it look like when it's already set up. These are the easiest type. So here we've got 3x minus 4y equals 10 and x plus 4y equals negative 2. They are already set up for elimination because we have opposite coefficients here. We have a negative 4y and a plus 4y. So this example is going to be the easiest type where it's already set up for elimination. So step 1 is supposed to be that you have x's on top of each other, y's on top of each other, and then the constants. That's already done. Step 1 is good. Step 2 then is to go ahead and start solving these with elimination. So if we just add these two equations together, we have 3x plus 1x, and then we have negative 4y plus 4y. Those will go together, and then 10 plus negative 2. So we're going to add these together. So 3x plus 1x is 4x. Now here we get 0. You don't have to write the 0. You can just write 4x. And this 10 minus 2, or 10 plus negative 2, is 8. So we end up with 4x equals 8. that's going to be very easy to solve for x. Just divide both sides by 4. You get x equals 2. Using elimination, you usually find the value of the first variable really fast, pretty simple. So x is equal to 2. Once we know what x is equal to, we go back and we plug it into either one of these original equations. I'm going to use the second one because it looks a little simpler because it's just x. So for step 3, and they're going to do this on another page, but I'm going to go ahead and do it here. You write down that equation, x plus 4y equals -2, and then I replace the x with 2, and I solve this for y. So subtract 2 from both sides, and we get 4y. -2 minus 2 is -4. So we're going to get that y is equal to -1. Step 4 then is to write this as an ordered pair. The 2 goes first, the x goes first, always. And then step 5, or the second part of step 4, is to check this. Now to check, just like when we did substitution, you're going to take this coordinate, the x and the y value, and put it back into your original set of system of equations. So it would be 3 times 2 minus 4 times -1. And I want to see, is that equal to 10? So 3 times 2 is 6. Minus 4 times -1, that would give me a plus 4 because there's 2 negatives. And 6 plus 4 is equal to 10, so it works in the first equation. But I also have to check it in the second equation, so I put the 2 in for x and the -1 in for y, and I want to see, is this equal to -2? So that's just 2. 4 times -1 is -4, and 2 minus 4 is equal to -2, so it works in the second one as well. So to check, you can just go back to your original equations, plug the coordinates values in, and see if you get true equations. If you do, then you know that your answer is correct. So this is them finishing up finding what y was. They got -1 just like we did. Write it as an ordered pair, and then here's our next problem. Okay, in this example we have y plus 3x equals -2 and 2y minus 3x equals 14. So the first step is just to make sure that our y terms are aligned in a row. Yep, our x's are together, and then our constants. So that's good. For step 2 then, we want to check and see if it is set up for elimination. So here we have a plus 3x, and here is a minus 3x. Those are opposite. One's a positive, one's a negative. They have the same number in front. So this is the easy type where they are set up for elimination. So all we need to do then is go ahead and add these two equations together. When we do that, 3x minus 3x cancel. They're eliminated, and we get 0. 1y plus 2y is 3y, and then -2 plus 14 is 12. You don't need to write the 0, so this is the same as 3y equals 12. Really quickly, we can find that y is equal to 4. Now, once you have the first variable, then step 3 is to find the next variable. So for step 3, we take what we got for y and we plug it back into one of our original equations. Now pick the equation that looks the easiest. The top looks easier than the bottom because there's no number in front of the y term. So I take my y value of 4 and I plug it in, and then I solve this for x. So I subtract 4. So 3x equals -6. And we get that x is equal to -6 divided by 3 is -2. So our next step would be to write that as an ordered pair. We have to find that first. There we go. -2, 4. And then you should check your answer into the original equations and make sure that it works. All right, on your worksheet you have two problems where they're going to be of this type, where they're basically already set up for elimination. Number 1, let's look at starting number 1 for you. We have minus x or -x plus y equals 5, and x minus 5y equals negative 9. Now there's no numbers to see that they are the same, like one's a negative and one's a positive. But we could put this as negative 1x and this is 1x. And then you'll see that negative 1x and 1x, those are opposites. So this is indeed set up, and our first step will be adding these two equations together. Negative 1x plus 1x is 0. You can write it if you want. And then I have plus 1y minus 5y. So 1 minus 5 is negative 4y. Don't forget the y there. And then 5 plus negative 9 is negative 4. So I don't really need that 0. I'm just going to erase it. And then you would solve this by dividing both sides by negative 4, and you'll get y equals 1 for your first value. Then you'll plug that back into one of yours and solve for x. All right, number 2, you can see that we have plus 3y and minus 3y. So when we add these together, your y term is going to eliminate, and you'll have 1x plus 2x, and then on the other side you'll have 14 plus negative 8, or 14 minus 8. So when two equations each contain the same term, like 2x and 2x, you can multiply one of the equations by negative 1. Remember to multiply each term by negative 1, which will change all of the signs. Then it should be set up for elimination. For example, here we've got 2x plus y equals negative 5, and 2x minus 5y equals 13. This is almost ready for elimination. If we just had one of these be a negative 2x, then it would be good. But they're both positive at this point, so you can't just add them together now, because you'd get 4x minus 4y equals 8. It doesn't. You can't go anywhere. You still have two different variables, an x and a y, so that doesn't do you any good. It doesn't do you any good to just add two equations together unless one of the terms will eliminate. So what we need to do is we need to pick one of these equations to multiply by negative 1. And I just picked to do the second one. So the first one stays exactly the same, 2x plus y equals negative 5. But on the second one, I'm going to multiply every single term. I should put a negative 1 over here too. Every single term will be multiplied by negative 1. What that does is it changes all of the signs. So the first equation I just wrote again, 2x plus y equals negative 5. But on the second one, I distributed that negative 1. So I'd get negative 1 times 2x is negative 2x. Negative 1 times negative 5y would be a plus 5y. And 13 times negative 1 is negative 13. So every single sign changed on the second equation. Now I can add them together. I have 2x and negative 2x. So now when I add my two equations together, the x term will go away. It's just going to be 0. And I'm just left with 6y equals negative 18. Divide both sides by 6, and you get that y is equal to negative 3. Divide by 6. Once you know what y is, you're going to plug it back into one of these equations in order to find x. And it looks like the top equation is going to be a little bit easier. So you'll write 2x plus y, but y is equal to negative 3. Let me simplify that a little bit. So 2x minus 3 is equal to negative 5. And then we have to solve that for x. So if we add 3 to both sides, we'd get 2x equals negative 2. X is equal to negative 1. So now we know the value of both x and y, so we can write that as an ordered pair. And we get negative 1, negative 3. I'm going to go back to this page. Negative 1, negative 3. And remind you about checking your work. So if I'm going to, I'll use red. If I'm going to check this, I would take 2 times the value of x, which is negative 1, plus the value of y, which is negative 3, equals negative 5. And I want to see if this is true. So 2 times negative 1 is negative 2, plus negative 3 is indeed negative 5. So it works in the top equation. In the second equation, I would take 2 times negative 1, minus 5 times negative 3, and I want to see if this equals 13. So 2 times negative 1 is negative 2. Negative 5 times negative 3 would be plus 15, and negative 2 plus 15 is indeed 13, so it does work. But it is a very, very good idea to go back and check your answers, take an extra minute or so, and be sure that what you wrote is correct. Especially do that if you end up with fractions or decimals, because you shouldn't. It is certainly possible to get a fraction or a decimal when you solve systems of equations. There's nothing wrong with that, except that on the worksheets that I've made for you, I've designed them so that you will get integer answers. So if you end up getting a fraction, you made a mistake somewhere. And then here's the problems from your book or from your worksheet. You can see that they're almost set up for elimination, except that in the example for number 3, we have x plus 1y and 2x plus 1y. If one of these was just a negative, then we could add them together and use elimination. Same thing in number 4. We have 1x minus 10y equals 60, and 1x plus 14y equals 12. Let's look a little bit, start number 4 for you. So on number 4, I'm going to take the second equation and I'm going to multiply both sides by a negative 1. So the first equation I'm just going to rewrite exactly the same as it was. Didn't change a thing. But on the second equation, when I multiply by negative 1, that changes the sign of every term. So negative 1 times 1x is negative 1x. Negative 1 times 14y is minus 14y. And 12 times negative 1 is negative 12. And now I'm ready to use elimination because now I have 1x and minus 1x. So you can go ahead. Whoa. I lost my spot. Was I here? Nope, that's too far. Here we are. Okay, so now I'm ready to go ahead and use elimination. And when I add these together, they will cancel. Negative 10y minus 14y is negative 24y. And 60 minus 12 is, let's see, that would be 8, 5, 48. And then you need to finish this, divide both sides by negative 24, and find what y is equal to. Don't forget that once you will find what y is equal to, you have to plug it back into one of your equations in order to find x, whichever one you think looks easier. It doesn't always have to be the top one, it's whatever one you prefer to use. And then again, remember to check your answers. Sometimes you have to multiply one of the equations by a number so that one variable has opposite coefficients. And sometimes you even have to multiply both equations by variables or by numbers so that you can have your equations set up for elimination. Here's an example. We have x plus 2y equals 11 and negative 3x plus y equals negative 5. Well, we have our x's lined up here and our y's lined up, and we can see that we do not have opposite terms. We don't have a negative 3x and a positive 3x, or a 2y and a negative 2y. So we need to get it ready for elimination. There's no sense in adding these together, it won't work. So you can decide, you can say, well, let's see. I could multiply the top equation, everything, by a 3. Now, why would I do that? Because then I would have 3x and a negative 3x. Don't forget you'd have to multiply everything by 3, so you'd also have a 6y and a 33. Or maybe you look at this and you say, no, I want to get rid of the y term. I could multiply everything on the bottom by a negative 2, because then I would have a negative 2y here plus 2y up there, and that would eliminate. So you need to look at it and decide, there's more than one way to solve these, what variable you would like to eliminate, and then what you need to multiply by in order to do that. I think it's a little bit easier to do the top one multiplied by 3, but let's go ahead and do the bottom one by negative 2. So we're going to leave the top equation exactly as it was, x plus 2y equals 11. But on the bottom, we're going to multiply every single term by negative 2. So when we do that, we'd have to use our distributive property on the bottom. So the top equation stays exactly the same, x plus 2y equals 11. But the bottom equation, we'd have negative 2 times negative 3x, that's 6x, and then negative 2 times y is minus 2y, and then negative 5 times negative 2 is a positive 10. Now we're ready to add our two equations together because now it's set up for elimination because our y term is a plus 2y and a minus 2y. It's exactly the way we want it to be. So now we can go ahead and add these two equations together. 1x plus 6x is 7x. Our y terms eliminate, we just get 0, and 11 plus 10 is 21. So we don't really need the 0 there, so we just write 7x equals 21, divide both sides by 7, and we find that x is equal to 3. Now don't forget, after doing all that work, you're still not done. Now that we know what x is, we have to plug that back into one of our two equations in order to find y. I think it's a little easier to use the second one. The reason I think that is because y is by itself, so it'll be easier to solve for y. Just a little bit easier. So step 3, which they'll do on the next page, but I'm going to start it here, would be negative 9 plus y equals negative 5. Now watch your negatives here. Don't make a mistake after doing all this work and get the wrong answer for your, just because you added wrong. Double check with your calculator if you have to. So we have our answer of 3 and negative 4 we got for y. They picked the other one to use to solve for y. You should still get the same answer. Oh, it was a positive 4. Did I say negative 4? No, I got 4. So when you use the other equation, you still get an answer of y equals 4. It should work in either one. You should get the exact same thing. Write your answer as an ordered pair, and then check by plugging back into your original equations and making sure it works. All right, here's your problems from your worksheet. You will have to set them up by multiplying one of the equations by a number in order to get it to work. So let's see, which one should we look at? Let's look at number 5. We have 2x minus 1y equals 20, and 3x plus 2y equals negative 19. Now there's nothing I can multiply either of the x terms by in order to get equal to the other one. So let's look at the y's. I have negative 1y and a plus 2y. If I just multiplied everything on the top by 2, then I would have negative 2y and a plus 2y in the bottom. So let's see. On the top, I'm going to multiply everything by 2. So I'd have 2 times 2x. Then I'd have 2 times negative 1y. That's negative 2y. And on the other side, I'd have 20 times 2. It's a common mistake to forget to multiply the right side by your number. So I always write it next to it so I don't forget. Now the second equation I didn't have to multiply by anything. I'm just going to rewrite it over here so they're next to each other and all lined up. Now that I have this set up for elimination, I can just add these two equations together because the x term now, the y term I have ready to go. I have a negative 2y and a plus 2y. So they will eliminate, and I'll end up with 7x plus 0. So 7x equals, and then you have to take 40 minus 19 and see what you get. The second one, you could either multiply the top equation by 2 in order for the x's to cancel, because then you'd have 4x and a negative 4x, or you can multiply the top one by negative 2, because then you'd have a negative 4y and a plus 4y. So you decide which one you would rather do. Don't forget that you need to multiply both sides of the equation by the same number. All right, finally, sometimes there's no way to multiply one equation by a number to make it have opposite terms with the other equation. So then you have to multiply both equations by numbers. Now it does not have to be the same number. It won't be the same number. So here's an example. 6x minus 5y equals 16 and 4x minus 3y equals 12. I can't multiply 6 by any integer to get 4. I can't multiply 4 by something to get 6. There's nothing I can multiply 5 by to get 3, and nothing I can multiply 3 by to get 5. However, I could multiply, let's see, 4 and 6. I could make both of the, I could multiply the top equation by 4 and the bottom one by 6, and then I'd have 24x and 24x. So that's almost what I want to do, but I also want one of them to be negative. Also, it might be easier if I find the lowest common multiple rather than just 4 times 6. Both of these numbers would go into 12. So instead of multiplying the top one by 4 and the bottom one by 6, I could multiply the top by 2 and the bottom by 3. So then I would have 12x and 12x. So instead of multiplying the top by 2 and the bottom by 3, I could multiply the top by 2 and the bottom by -3. And that way, I would have this all set up for elimination. All right, let's look at an example step by step. So here we have -5x plus 2y equals 32 and 2x plus 3y equals 10. So I've got a -5x and a 2x, those can't be eliminated yet, and a 2y and a 3y, those can't be eliminated yet. So what I need to do is figure out how I could get opposite coefficients. And I think I'll look at the x's because I already have one of them being a negative and one being a positive. So let's see, I have a 5 and a 2. They would both go into, 5 and 2 both go into 10. So if I multiplied the top equation by 2 and the bottom equation by 5, pretty much just the opposite, multiplying by what the other equation's coefficient is, then I would have 10x and -10x for my x terms. Let's see how that'll work. So the top equation then becomes, and again, I'm going to multiply both sides, so I want to make sure I don't forget that. The top equation will change to 2 times -5x is -10x, 2 times 2y is 4y, 2 times 32 is 64. The second equation would be 5 times 2x is 10x, 5 times 3y is 15y, and 5 times 10 is 50. Now they are set up for elimination. All I need to do is add them together, and the x term will cancel because I have -10x plus 10x. So 4y plus 15y is 19y, 64 plus 50 is 114. I'll use my calculator to divide and find that that is y equals 6. Once you find y, we still need to plug it back into one of the equations, the original equations, in order to find x. So we get 2x plus 3 times 6, because that was our value of y. We found y equals 6. 3 times 6 is 18, and we finished solving this for x using the skills that you learned in algebra first semester. So 2x equals -8, x equals -4. Divide both sides by 2. Write that as an ordered pair and check your answer, and you're all done. On your homework, on your worksheet, you have 2 of these to do. So let's look at what we could multiply our equations by in order to eliminate one of our variables. We have 9x and 4x. So both of those numbers would go into 36. 9 times 4 is 36. So I could multiply the top equation by 4 and the bottom by, let's say, -9. So it would be 36 and -36. Or maybe we want to eliminate the y values, the y variables. So that might be a little bit easier. We have a -2y and a +3y. And their product is 6. So I could multiply the top equation by a 3 and the bottom equation by a 2, which would result in, let's write what we would have then. So 3 times 9 is 27x. 3 times -2y would be -6y. 15 times 3 is 45. So now I've got a -6y for the middle term here. The bottom equation would be 2 times 4x is 8x. 2 times 3y is 6y. There we go. And then -5 times 2 is -10. So this is going to work well because now we have a negative 6y and a plus 6y for our y terms. And when we add these together, the y term will eliminate. So 27x plus 8x is, let's see, 35x. The y's are gone, it's 0. And then 45 minus 10, that's kind of nice, is 35. So we divide both sides by 35, we're going to get x equals 1. Now don't forget to go back over here and plug back in. Let's use the second equation. We'd have 4 times 1, and we still need to find what y is equal to here. So I'm going to subtract 4 from both sides and get positive 3y equals negative 9. Divide by 3, and y is equal to negative 3. Then we write this as an ordered pair. The x always, always, always goes first. And then we check. So to check, I'm going to do it over here. I'll use red to check. I'm going to write both equations, but instead of putting an x, I will replace it with 1. And wherever I see a y, I will put negative 3. And I want to see if this is equal to 15. So that would be 9. Minus 2 times negative 3 would be a plus 6. And does that equal 15? 9 plus 6 is 15, so it checks. In the second equation, I have 4. Use the original equations to check. Times 1 plus 3 times negative 3. And I want to see if that's equal to negative 5. So 4 times 1 is 4. 3 times negative 3 is negative 9. And I want to see if that's equal to negative 5. And it is. It checks. So this is a good answer and ready to move on. All right, so that's it. Take your time with these, check your work, and ask me if you have any questions. Have a wonderful day. Thank you very much.